In September 2020, something quietly happened that should have changed everything. A team of astronomers pointed their telescopes at the last planet anyone would associate with life. And what they found made them check their instruments 3 times before they believed it. They found a gas that should not exist there. A molecule that on Earth only comes from 2 sources: laboratories and living things. This is not speculation. This is peer-reviewed data from the James Clerk Maxwell Telescope in Hawaii and the Atacama Large Millimeter Array in Chile. 2 of the most powerful observation systems humanity has ever built. And they both confirmed the same thing. Something strange is happening on a world we wrote off decades ago. A planet so brutal, so hostile, so impossibly violent that we turned our backs on it to chase Mars instead. But Mars might not be the answer. The answer might be floating right next door, in the clouds of hell itself. I need you to understand something about space exploration that most people never consider. For the past 50 years, we have been obsessed with one idea. We believed that if life exists beyond Earth, it must be hiding underground. On Mars, on Europa, on Enceladus. We pictured microbes clinging to frozen rocks beneath alien soil. We imagined bacteria huddled around hydrothermal vents in dark subsurface oceans. That made sense to us. Water means life. Ice means protection. Depth means safety from radiation. So we built rovers to dig. We designed probes to drill. We spent billions of dollars preparing to search underground because that is where logic told us to look. But what if we were looking in the wrong direction entirely? What if life does not hide from the universe? What if it floats through it? I remember the first time I looked at detailed images of Venus. I was younger then, still learning that the universe rarely matches our expectations. Venus looked like a marble wrapped in cream, beautiful from a distance, smooth and golden and almost inviting. It orbits closer to the Sun than Earth does, but not by much. It is nearly our twin in size. 95% of Earth's diameter. 80% of Earth's mass. Scientists once believed it might harbor jungles, oceans, perhaps even civilizations. In the 1960s, the Soviet Union sent the Venera probes to find out the truth. What they discovered destroyed every romantic notion humanity had ever held about our sister planet. The surface temperature of Venus reaches 475 degrees Celsius. That is 900 degrees Fahrenheit. Hot enough to melt lead. Hot enough to glow red in the darkness if you could somehow see through that crushing atmosphere. And the atmosphere itself is a nightmare. The pressure at the surface equals what you would experience nearly a kilometer underwater on Earth. The air is 96% carbon dioxide. Clouds of sulfuric acid drift through the sky. Lightning storms rage without pause. The winds at altitude scream at 360 kilometers per hour. The Venera landers survived between 23 minutes and 2 hours before being crushed, cooked, or dissolved. The images they sent back showed a landscape of volcanic rock baking under an orange sky. No water, no life, no hope. Venus became a cautionary tale, a greenhouse effect run wild, a warning about what Earth could become if we failed to protect our climate. Scientists moved on. Mars became the focus. Europa became the dream. Venus became the planet we visited only in cautionary climate models. For nearly 4 decades, we barely looked at it again. Then Dr. Jane Greaves decided to check something everyone else had forgotten to check. Jane Greaves is an astronomer at Cardiff University. She specializes in studying the chemical signatures of planetary atmospheres. In 2017, she had a thought that would eventually shake the foundations of astrobiology. She wondered what Venus might look like if she examined it the way she examined distant exoplanets. She wondered what molecules might be floating in those sulfuric clouds. She wondered if anyone had ever really looked. No one had. Not with modern instruments. Not with the sensitivity we now possessed. So she looked. On June 11, 2017, the James Clerk Maxwell Telescope in Hawaii turned its attention to Venus. It detected electromagnetic radiation at a specific wavelength, 1.123 millimeters. This wavelength corresponds to the rotational signature of a molecule called phosphine. Phosphine is 3 hydrogen atoms bonded to 1 phosphorus atom. On paper, it seems unremarkable. In reality, it is one of the most significant molecules in the search for life. Here is why. On gas giant planets like Jupiter and Saturn, phosphine exists naturally. Those planets have immense internal heat and crushing pressures deep in their atmospheres. Under those conditions, phosphine can form through pure chemistry. No biology required. But on small rocky planets like Earth or Venus, the conditions are completely different. There is not enough heat. There is not enough pressure. The chemistry does not work. On Earth, phosphine appears in exactly 2 situations. Industrial manufacturing, where we create it deliberately for specific purposes, and anaerobic microbial life, where certain bacteria produce it as a metabolic byproduct. That is it. Those are the only known pathways on a rocky world. When Dr. Greaves detected phosphine on Venus, she assumed she had made an error. The signal was weak. The data could be misinterpreted. Atmospheric chemistry is fiendishly complex. She waited 2 years. Then she requested time on an even more powerful instrument. The Atacama Large Millimeter Array in Chile consists of 66 radio telescopes working together as one. It can detect molecular signatures with extraordinary precision. In March 2019, ALMA turned toward Venus and recorded data for several hours. The phosphine signal was there, stronger and clearer than before. Dr. Greaves assembled a team of experts from the United Kingdom, the United States, and Japan. They spent 18 months trying to prove themselves wrong. They calculated every possible non-biological source of phosphine they could imagine. Volcanic activity, lightning strikes, meteorite delivery, photochemical reactions in the upper atmosphere, solar-wind interactions, mineral erosion, exotic chemistry involving sulfuric acid. They ran the numbers again and again. None of it worked, not even close. The volcanic model came the closest, but it would require 200 times more volcanic activity than Earth experiences. There is no evidence Venus is remotely that active. Lightning could produce tiny amounts, but nowhere near the concentration detected. Every pathway they tested fell short by factors of 10,000 or more. On September 14, 2020, their paper appeared in Nature Astronomy. The title was cautious. The conclusions were measured, but the implications were staggering. 20 parts per billion of phosphine floating in the temperate zone of the Venusian atmosphere, between 48 and 60 kilometers above the surface. Exactly where the conditions become almost Earth-like. I need to tell you about that zone, because it changes everything about how we should think about Venus. The surface of Venus is uninhabitable. Nothing we know of could survive there, but the atmosphere is layered. And as you rise through those layers, something remarkable happens. At approximately 50 kilometers altitude, the temperature drops to around 25 degrees Celsius. That is 77 degrees Fahrenheit. Room temperature on Earth. The pressure at that altitude is roughly 1 atmosphere. Exactly what you experience at sea level right now. The gravity is similar to Earth's. The radiation protection from the thick atmosphere above is substantial. And while the clouds still contain sulfuric acid, they also contain water droplets and nutrients that certain extremophile organisms might theoretically utilize. Carl Sagan proposed this idea in 1967. He and Harold Morowitz wrote a paper suggesting that life could exist in the Venusian clouds. floating colonies of microorganisms riding the winds, reproducing in the temperate zones, dying when they sink too deep but regenerating from spores carried upward by convection. For 50 years, everyone dismissed this as speculation. Beautiful speculation, but speculation nonetheless. Now we have phosphine exactly where Sagan said life might exist. I want you to understand the weight of that coincidence. We detected a biosignature gas in the only layer of the Venusian atmosphere where life as we know it could potentially survive. Not at the surface, not in the upper reaches, in the exact altitude range where temperatures and pressures match Earth. The statistical probability of that being a coincidence is troubling. But there is something else. Something that makes this even more difficult to dismiss. The phosphine detection revealed an anomaly that scientists initially overlooked. The molecule is being destroyed constantly by sunlight and chemical reactions in the Venusian atmosphere. It should disappear within a few years unless something is actively replenishing it. Something is actively replenishing it. Whatever produces the phosphine must be doing so continuously. Day after day, year after year. The reservoir is being topped up at a rate that cannot be explained by any geological process we currently understand. On Earth, the organisms that produce phosphine are anaerobic bacteria. They live in oxygen-free environments. Swamps, sewage, the intestines of animals. Anywhere that oxygen is absent and organic matter is present. The clouds of Venus are largely oxygen-free. They contain abundant sulfur and carbon. They have liquid droplets that could serve as microhabitats. They have vertical circulation that could distribute a population throughout the temperate zone. The environment matches the requirements disturbingly well. After the initial announcement, criticism came swiftly. This is how science should work. Extraordinary claims require extraordinary evidence, and the scientific community was determined to test every alternative explanation. Some researchers questioned the data processing. They argued that the spectral signature might have been an artifact of how the telescope data was calibrated. A team from NASA's Goddard Space Flight Center published a reanalysis suggesting the phosphine signal might be weaker than originally reported. Dr. Greaves and her team acknowledged the criticism, reviewed their methodology, and published updated results. The signal remained, perhaps at 10 parts per billion rather than 20, but still present, still unexplained. Other researchers proposed that the phosphine might come from atmospheric chemistry we do not fully understand. Venus has an extraordinarily complex atmosphere with dozens of chemical interactions occurring simultaneously. Perhaps some unknown reaction pathway exists that we have not yet discovered. This is possible. Science is always limited by what we currently know. But this explanation requires inventing new chemistry specifically to avoid the biological hypothesis. It requires assuming that Venus has unique reactions that occur nowhere else in the solar system. The simplest explanation remains the most uncomfortable one. In 2021, NASA announced 2 new Venus missions. DAVINCI Plus will drop a probe through the Venusian atmosphere, sampling its chemistry as it descends. Veritas will map the surface with advanced radar to understand the planet's geological history. The European Space Agency announced Envision, which will conduct detailed atmospheric and surface studies. India announced Chakrayan. Russia proposed reviving its Venera program. China outlined plans for a Venus orbiter. Within 1 year of the phosphine announcement, 5 major space agencies committed to missions targeting a planet that had been largely ignored for 3 decades. This does not happen without reason. Scientists are cautious by nature and training. They do not redirect billions of dollars in mission funding based on inconclusive evidence. Something about the phosphine detection convinced the people who make these decisions that Venus deserves urgent attention. I think about what this would mean if the biological explanation is correct. We have spent 60 years scanning the skies for radio signals. We have sent probes to Mars searching for fossils of ancient microbes. We have looked at moons around Jupiter and Saturn hoping to find oceans where life might hide. We have pointed our most powerful telescopes at stars thousands of light years away, hoping to detect biosignatures on distant exoplanets. And the entire time, life may have been floating in the clouds of the planet next door, 40 million kilometers away at closest approach. A few months of travel with current propulsion technology, close enough that we could send a probe to directly sample the atmosphere within a decade. If there are microorganisms drifting through the sulfuric clouds of Venus, they represent something almost incomprehensible. An independent origin of life. A second genesis. Proof that biology is not a cosmic accident but a natural consequence of chemistry under the right conditions. Or perhaps something even stranger. Some scientists have proposed that life might have originated on Venus billions of years ago, when the planet likely had liquid water oceans on its surface. As the sun grew brighter and Venus began its catastrophic greenhouse warming, that life might have adapted. It might have retreated upward into the cooling clouds. It might have learned to survive in sulfuric acid because the alternative was extinction. If this is true, then Venusian life would be our closest relative in the cosmos. Perhaps our ancient cousin, evolved from similar chemistry during the early days of the solar system when conditions were more favorable. There is an even more unsettling possibility. Rocks travel between planets. We know this because we find Martian meteorites on Earth, blasted free by ancient impacts and drifting through space until gravity captures them. The same process works in reverse. Earth rocks have certainly landed on Mars. And on Venus. If life originated on one of these three worlds, it may have spread to the others through panspermia. The seeding of planets by microbial hitchhikers riding meteors through the void. We might be related to whatever lives in those clouds. We might share ancestors. The bacteria in your gut and the hypothetical organisms of Venus might have common origins stretching back 4 billion years. I need to tell you about what happened in 2023. A team led by Rakesh Moghul at California State Polytechnic University re-examined data from the Pioneer Venus mission, which arrived at Venus in 1978. They were looking for something everyone had missed. They found it. The large probe that descended through the Venusian atmosphere in 1978 carried a mass spectrometer. This instrument analyzed the chemical composition of the clouds during descent. The data from that instrument has been publicly available for over 40 years. Moghul and his team found signatures consistent with phosphine in that 45-year-old data. They also found possible evidence of other molecules that should not exist in the Venusian atmosphere according to conventional chemistry. The Pioneer Venus probe may have flown directly through clouds containing life in 1978 and never realized it. This is one of the most haunting aspects of this story. We may have already encountered extraterrestrial life. We may have collected evidence of its existence. And we may have filed that evidence away in databases that no one examined carefully for 4 decades because we were not looking for what was there. We were so focused on Mars, so certain that Venus was sterile, so confident in our assumptions about where life could and could not exist. What else have we missed? The James Webb Space Telescope, which launched in December 2021, has the capability to analyze the atmospheres of Venus in unprecedented detail. Observations are being planned. Results will follow. The DAVINCI Plus mission is scheduled to launch in 2029. Its descent probe will spend approximately 63 minutes falling through the Venusian atmosphere, sampling gases and capturing images the entire way. It will pass directly through the cloud layer where the phosphine was detected. If there is life in those clouds, DAVINCI Plus might photograph it, or detect its chemical byproducts, or find other anomalies that point toward biological activity. We are less than 6 years from potentially confirming or refuting one of the most significant scientific hypotheses in human history. Think about where you were in 2019. Think about everything that has happened since then. That same amount of time separates us from answers that would reshape our understanding of existence itself. I want to leave you with something to consider. Venus was our sister planet. Born from the same cloud of gas and dust, made from the same materials, formed at roughly the same time. For the first billion years, it may have been more Earth-like than Earth itself. Oceans, moderate temperatures, perhaps even continents. Then something changed. The sun grew hotter. The oceans evaporated. The water vapor created a runaway greenhouse effect. The planet became the hell we see today. But life is tenacious. Life adapts. Life finds a way into every environment that can possibly sustain it. If life existed on ancient Venus, and if that life somehow survived the transformation of its world by retreating into the clouds, then it has been floating in that sulfuric sky for perhaps 2 billion years, evolving in isolation, adapting to conditions we consider impossible, developing biochemistry that Earth life has never dreamed of. Those organisms would not be primitive. 2 billion years of evolution produces complexity. 2 billion years of adaptation produces ingenuity. 2 billion years of survival produces resilience we cannot imagine. What would life become after 2 billion years in the clouds of hell? We are about to find out. I have spent years studying data from missions across the solar system. I have seen patterns that defied explanation until new evidence revealed the truth. I have learned that the universe consistently surprises us, that our assumptions are often wrong, that the places we ignore are sometimes the places we should have looked first. Venus was the last place anyone expected to find evidence of life. It was too hot, too acidic, too alien, too hostile in every measurable way. And yet, 20 parts per billion of a gas that should not exist, detected in the only layer of the atmosphere where life could survive, continuously replenished by an unknown source, confirmed by multiple independent observations, unexplained by any known chemistry despite years of attempts. The evidence is not conclusive, but it is compelling, and it points in a direction that most scientists were not prepared to consider. Life may not be rare in the universe. Life may not require perfect conditions. Life may thrive in clouds of sulfuric acid around a planet that looks like biblical perdition from the surface. If Venus has life, then life is everywhere. In atmospheres, in oceans beneath ice, in cracks in asteroids, in places we have never thought to look because our imaginations were too limited to conceive of the possibilities. The next decade will tell us whether we are alone. Not alone in the galaxy, not alone in the distant cosmos, but alone in our own solar system, our own celestial neighborhood, the handful of worlds we can reach with current technology. That answer is waiting for us in clouds the color of sulfur and fire, and I believe we are finally ready to go find it. Now I need to ask you something. If we confirm life exists in the clouds of Venus, everything changes. The philosophical implications alone would reshape how humanity sees itself. We would know that biology is not unique to Earth, that we are part of a living universe rather than an anomaly within it. But there is a question that haunts me. If life exists on Venus, what are the ethical implications of exploring that world further? Of sending probes that might contaminate those clouds? Of potentially affecting an ecosystem that has evolved in isolation for billions of years? We have protocols for planetary protection. We sterilize our spacecraft. We try not to contaminate other worlds with Earth microbes. But what about contaminating other worlds with our presence? Our technology, our curiosity. If there are organisms floating in those sulfuric clouds, do they have a right to exist undisturbed? Do we have a right to study them, to capture them, to bring them back to Earth for analysis? And what happens when we do? I want to know what you think. Tell me in the comments. Do we have the right to disturb whatever might be living in the clouds of Venus? And if you found out tomorrow that life definitely exists there, how would it change the way you see our place in the universe? I will be reading every response.